What is a large language model? And the answer is option B. An LLM is not a database. It's not storing your questions and looking up saved answers like Google does. What it actually does is much simpler at its core and much cooler once you get it. It's a neural network trained on a huge pile of text, and its main skill is predicting the next word. Think about the autocomplete on your phone keyboard. You type I'm on my way and it suggests home. That's a tiny dumb version of the same idea. An LLM is that same trick but scaled up massively trained on basically a huge chunk of the internet and repeated one word at a time until it can write full paragraphs, code, essays, whatever. So when someone asks you this in an interview, the key thing to say is it's a prediction machine, not a lookup machine. That distinction alone explains a lot of LLM behavior, including why it can sometimes get facts wrong. What is a token in the context of LLMs? And you guessed it right. The option D is the answer. Tokens. This one comes up constantly in interviews. Imagine language as Lego blocks instead of solid blocks. A model doesn't read unbelievable as one whole word. It might break it into pieces like un, believe, and able. Those pieces are tokens. Why does this matter? Because everything about LLM, pricing, speed, memory limits is measured in tokens, not words or characters. When someone says, this model has a 100k token limit, that's basically saying how many Lego pieces it can hold in its hands. Roughly in English, one token is about three quarters of a word, so 100 words is roughly 130 tokens. Doesn't need to be exact for an interview, just know that tokens are the actual currency the model thinks in, not words. What is the transformer architecture primarily known for introducing? And it's option A. This is probably the single most important idea behind every modern LLM. Before transformers, older models read text basically one word after another, kind of like reading with a narrow flashlight. By the time you reach the end of a long sentence, you have almost forgotten the beginning. Now imagine reading the same sentence, but you can shine a spotlight on any word in the sentence at any time, based on what's actually relevant right now. Take the sentence, the trophy didn't fit in the suitcase because it was too big. What does the word it refer to? The trophy or the suitcase? A human instantly knows it's the trophy because the attention lets you connect the word it back to the right word based on meaning, not the position. That's literally what the attention mechanism does mathematically. For every word, it calculates how much it should pay attention to every other word in the sentence. This one idea from the famous 2017 paper, Attention is All You Need, is the entire foundation GPT, Claude, and basically every other modern LLM is built on. What does context window refer to in an LLM? And it's option C. Think of the context window as the model's short term memory, or honestly, like the size of your desk while you're working. You can only fit so many papers on the desk at once. If you keep adding new documents, eventually the oldest ones fall off the edge and you can't see them anymore. That's what happens with the context window. If a model has, say, around 32,000 token context window, that's the maximum it can see at once. Your entire conversation, any documents you have pasted in, etc. Once you go past that limit, older parts of the conversation literally gets pushed out of that and the model forgets them, even if you mentioned something important 5 messages ago. This matters a lot in real interviews because it directly connects to something like RAG. Instead of trying to cram an entire company's documentation onto that desk, you only hand the model the specific relevant pages it actually needs for this question. Small desk, but you're smart about what you put on it. What does temperature control when generating text with an LLM? The answer is option B. Temperature is basically a creativity dial, and it's a really common interview question because it's easy to test if you actually understand it or just memorize the word temperature. Here's the intuition. At every step, the model is not just picking one correct next word, it's actually calculating the probabilities for a bunch of possible next words. At low temperature, close to zero, it almost always just picks the single most likely word. Safe, predictable, and a bit boring. Great for something like generating code or factual answers where you don't want surprises. At high temperature, it's more willing to pick a less obvious, more surprising word. Great for creative writing, brainstorming, poetry, where you actually want some unpredictability. It's something like ordering food. Low temperature is you always ordering your usual safe dish, and high temperature is you occasionally trying the weird special on the menu. Same restaurant, same menu, just how adventurous you are willing to be. That's the dial temperature controls. What is prompt engineering? The answer is option D. Prompt engineering sounds fancy, but honestly, it's something you already do in real life without realizing it. Think about asking a coworker for help. If you just say, fix this, you'll probably get a confused, unhelpful response. But if you say, hey, this function is throwing a null pointer error on line 42, can you check if it's related to the recent database change? Suddenly you get a way better answer because you gave a clear, specific context. And that's prompt engineering with an LLM. The model itself does not change at all. You are not retraining anything, not touching any code inside it. You are just being deliberate about how you phrase the instruction, giving examples, specifying format, breaking a big task into steps to steer the model toward a genuinely useful answer instead of a vague one. In interviews, this is where you would mention things like giving the model a role, act as a senior code reviewer, giving it examples, or asking it to think step by step, all just different techniques under the same umbrella. What does fine tuning mean in the context of LLMs? The answer is option A. Here's a clean way to think about fine tuning. Imagine a medical school graduate. They have got a huge base of general medical knowledge from years of school. That's like the pre trained LLM. Now, if that person goes on to do a cardiology residency, they are not starting from zero. They are taking that general foundation and specializing it further, using focused training on a hard specific cases. Similarly, you take a model that's already been trained on a massive general data set, books, articles, code, all sorts of stuff, and then you continue training it on a smaller, more focused data set for your specific use case. Say a company wants a model that's really good at answering questions about their internal software tools. They would fine tune a general model on their own internal documentation and support tickets. The key interview point here is that fine tuning updates the model's actual internal weights, unlike prompt engineering or RAG, which don't touch the model at all. They just change what you show it at the moment of asking. What is hallucination in the context of LLMs? The answer is option C. This one's genuinely important and it comes up in almost every other AI interview these days. Remember how we said an LLM is a prediction machine, not a lookup machine? Hallucination is the direct downside of that. Picture a confident student in an exam who doesn't actually know the answer, but instead of saying, I don't know, they write something that sounds convincing, anyway, using a confident tone, reasonable sounding structure, even though it's completely wrong. That's basically what a hallucinating LLM does. It's not lying on purpose, it doesn't even know it's wrong. It's just generating the statistically most plausible sounding next words, and sometimes that lands on something false. This is exactly why techniques like RAG exist, giving the model actual source documents to ground its answer in, instead of relying purely on its trained in, sometimes fuzzy memory. In an interview, if you are asked how would you reduce hallucination, mentioning RAG, grounding the model in retrieved facts, or asking it to cite sources are all strong answers. What is the difference between zero shot and few shot prompting? The answer is option B. Imagine training a new intern on how to write a customer support reply. Zero shot is like just telling them, write a polite reply to this customer complaint. No examples. You are trusting they already generally know how to do this based on common sense. Few shot is different. You show them two or three example complaint and read reply pairs first, and then ask them to write a new one in that same style. You are not retraining the intern permanently. You are just giving them a quick reference right there in front of them before they attempt the task. That's the exact same idea with an LLM prompt. Zero shot means you just ask directly, trusting the model's general training to handle it. Few shot means you input a couple of example input output pairs directly inside your prompt, which usually makes the output more consistent and closer to the exact style or format you want. Really useful when you need a very specific structure like a certain JSON format or a tone of voice. In a model name like 7B or 70B, what does the number represent? The answer is option D. So when you see a model called Llama 7B or 70B, that number is referring to parameters, basically the number of adjustable knobs inside the neural network that get tuned during training. 7 billion means 7 billion of these little numeric knobs all working together. Here's a decent analogy. Think of parameters kind of like the connections between neurons in a brain. More connections generally mean the system can represent more complex patterns and knowledge. So, a 70 billion parameter model is generally more capable than a 7 billion parameter one, assuming similar training quality. But, and this is a great thing to bring up in an interview to show depth, bigger is not automatically better in every situation. More parameter means more GPU memory needed, slower responses, and higher cost to run. So, in the real world, a company might actually choose a smaller model on purpose if it's fast enough and accurate enough for their specific task, rather than always reaching for the biggest one available.